This is the last section that we're going to look at regarding statistics, and we're going to look at kind of a major concept within statistics, and that's looking at the normal curve. The first thing we're going to do is we're going to kind of look at some preview information that'll hopefully prime our brains for better understanding of the normal curve, and then we'll go into more of the nitty-gritty behind the concepts. So we're going to first start off by looking at annual salaries for two different companies, Company A and Company B. Now these are stem and leaf plots. They've labeled the stems and they've labeled the leaves, and they've told us that these are in thousands of dollars. So when I look at this first stem and leaf, we have it as 16, but because it's in thousands of dollars, we would write that as 16,000. So in this stem and leaf, we have two leaves, so that represents 22,000 and 24,000. Okay, so forth and so on for both of these lists. So what we're going to do is we're going to fill in the frequency distribution for each of these companies. So we're just going to tally how many times each salary appears in for each of these companies. So we have our two different frequency tables or frequency distribution charts for each of the companies, Company A and Company B. I just took the value of how many leaves there were under each of those stems, and that was able to use that to fill in the information in the frequency distribution chart. Now we're going to make a histogram for each company on two separate axes, but use the same vertical scale. So vertical scale. So I've drawn my axes. I have my frequency going up on the y-axis. This label here is going to apply to both of these charts. And same thing on the bottom, I've labeled the salaries in thousands. So I have 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, so forth and so on. Now remember that the 10,000 to 19,999 class stops right at 20, and so the bars will touch in our histograms. So now we're going to fill in our bars for this histogram. And here we have our two histograms. We have the Company A's histogram represented in red on the left, and we have a histogram for Company B in blue on the right. So you can see the differences in the frequencies of the different types of salaries. Next step is to create a box plot for each company. And so what I've done is I've listed out, remember these are in thousands of dollars, but I'm just writing down the 10 part of that. So it'd be 16,000, 22,000, 24,000, 32,000, so forth, so on. But I'm going to write out the list of these numbers so that I can figure out what we need for a box plot. Because if you recall from our previous section, we need to know the min, the max, the Q1, Q2, Q3. The Q2 is our median, while Q1 is the median of the first half of the data, and Q3 is the median of the second half of the data, or the upper values versus the lower values. Then we're going to use the rule Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR to find out if there are any outliers, which will answer the second part of this question. In order to do this, I need to draw a consistent number line. I'm going to do so below. I'll pause and do that so you don't have to watch me mark tick marks. So I've drawn my number line, and now for each of these sets, I'm going to determine the median and the Q1 and Q3. So I'm going to go ahead and mark those. There are 11 values in each of these sets, and so the middle number would be the sixth mark, or the sixth data piece when it's ordered. So that's 1, 2, 3, 4, 5, 6. So 40 in the first set. For Q1, I'm going to look at the remaining 5 values and find the one that's in the middle there. And then the same thing for the upper half. So my Q1 for the first set is 24, the Q2 in the median is 40, and the Q3 is 45. We're going to do the same thing for the second set of numbers. And now we're going to draw our box plot. So I'm going to show one box plot for the top, the first set, and then pause and just put the other one. I'm also going to erase some of the extra stuff right here just so that we have space. Starting off for the first set, I'm going to do it in red. Our first value, our minimum is 16, so I'm going to mark that right here. Our Q1 is at 24, so I'm going to make a longer line there. Our median is at 40, which would be approximately right there. Notice that my scale went by 3s on the number line just because that gave me enough space to put everything without counting by 1s. Our Q3 is 45, and then our highest value is 62. So I'm going to go ahead and make my box, and then I'm going to make my whiskers. Now remember, after I check for outliers, the whiskers might change. So we're not married to this yet until we check for outliers. Okay, then we do the same thing for the blue set. I'm going to do that while being paused. In this example, for the blue data set, the minimum is 33, the Q1 is 34, the median Q2 is 40, and then the Q3 is 45, but the maximum is also 45. So there is no whisker on this one because the whisker and the Q3 are the same. So now we got to check for outliers. So we have to find our IQR for each of these. So remember, the IQR is equal to the Q3 minus Q1. So on this top one, on this first set, it's 45 minus 24, which equals 21. And then for the blue set, the IQR would be, again, Q3 minus Q1. So that's 45 minus 34, and that is 11. Okay, then we check the highest and lowest values with the rule Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR and check for any outliers. I'm going to do that off the camera. So the lowest value for outliers, or the number that demarks any outliers for the first group, would be at negative 7.5, which none of our values are past negative 7.5. And remember that that's in thousands, so that would be negative 7,500. But then the upper limit for outliers would be anything past 76.5, which we don't have anything there. Our highest value is 62, which is not beyond the limit for outliers. Same thing happens for the second set. There are no outliers. So then we look at this question D. It asks, what value does blank percent of the population earn more than? Mark this on your histogram. So essentially it's asking, what do these marks for Q1, Q2, and Q3 show? So let's do this for the red bunch. I'm going to write it out in dark gray. So we're first going to think of, what value does 75% of the population earn more than? So remember, these quartiles break it up into quarters, 4 pieces, and it tells us how, like, a visual representation of how many values are in each quarter of the data. So if I'm trying to figure out what value or what salary does 75% of the population earn more than, that's going to be your Q1, because Q1 splits it up into 25% in the first quarter or quartile, and then 75% in the remaining 3. So this value right here, that Q1, which is 24 in that top set, means that at 24,000, if that's your salary, 75% of the other employees in the company make more than you. Okay, that's how we would interpret that. So then if I'm trying to ask the question, what about 50%? Which value does 50% of the company earn more than? So at what point, which of our values gives us the value where 50% more of the company, or 50% of the company, would earn more than that? And that's going to be our Q2, because the Q2 is our median, and it splits our data into 50%, because it's 1/2 on one side and 1/2 on the other. So half of our data is below the median and half of the data is above the median. And so therefore, we would say in the first salary situation, at $40,000, half of the population earns more than that,
We could also say at the median at $40,000 that half of the company makes less than that. So then hopefully you realize the last question, the pattern, and it asks what value does 25% of the population earn more than? Okay, so Q3 tells us the value that splits it up into 25% makes more and 75% makes less. So that's how these quartiles break up the data. Like the quartiles are actually incredibly helpful. If I know that 50% of the people in both of these companies make more than 40,000 and less than 40,000, that doesn't really help me that much. But if I know that out of these two companies that have a Q1 of 34,000 for the blue one and 24,000 for the red one, if I know that 75% of the people earn more than $24,000, whereas in the company two, 74% or 75% earn more than $34,000, that kind of tells you something. Okay, now looking at these, you can get some other information that's really helpful. Nobody in set 2 makes more than $45,000. So that Q3 is the same as the maximum. That doesn't tell us very nice information, okay? Or not helpful information if you're planning on trying to work there, because the maximum value is the same as what the Q3 is. So that means that essentially 25% of their company makes 45,000. And then everybody else, 75%, makes less than 45,000. So that's how we interpret these box plots, but it also gives us a beautiful representation of what's happening. Okay? Point out, I'm not gonna lie, the wording of this question bothers me because it's very, I feel like sometimes it can be very confusing. So I have to pause very carefully and read what's happening. So when it says, what value does 25% of the population earn more than? I have to think of like that mark tells me more on the left, or sorry, more on the right side. These people earn more. These people earn less. Okay, so I'm going to be really honest. I have to really pause to think about these types of questions. So if it takes you a minute to think it through, that's completely understandable because like you're thinking about breaking this up into quarters and into halves and thinking about which half is more than versus less than. Because if I said, what value does 25% of the population earn less than? That would be Q1. So it's just understand that I know it takes a little bit of time interpreting these. And this last question, these are kind of feelings questions, and everyone might have a different reason. But it says, if you were on the low end of the salary scale, would you rather work for company A or company B? And gut instinct hopefully points you towards company B because the lowest salary for company B is 33,000 and the lowest salary for the first company or company A is 16,000. And so clearly if I'm on that lower end or maybe in that first quartile, I would want to make more in that first quartile. But some people might argue that the highest you could even go based on the examples we see and the data we see is 45,000 at company B, whereas there are a few people who make 60,000 or more at company A. And so these kinds of interpretation questions, you want to use the facts like what you're dealing with. I would say if I were on the low end of the salary scale and I was hanging out in Q1, I want to work at company B. If I'm because if I'm comparing these two quartiles, all these people are making more than all of these people. And honestly, even if I'm in the first half, right here, these values, like look at where the box is. These values in the first half are at or higher than all the values in the company A. Okay, and so that if I'm on the lower end of the salary scale, I'm probably going to want to be in company B. But if I'm in the higher end of the salary scale, $40,000 or more, I want to be company A. Okay, because they clearly have more room for higher salaries than the company B because the company B's maximum is lower. So statistics is all about interpreting information as it's presented to you, and the box plot is just another way to present that we've seen already, but it's going to tie into what we're looking at when we look at the normal curve. So I've already discussed if I was on the low end, I'd want to be in company B. If I were on the high end, I'd want to be in company A. Then we're going to identify each company's measures of center. So I'm going to go ahead and say we already know that the median for the red set is 40 and the median for the blue set is also 40. Let's look at the values. Here we go, and try to find our mode. The mode for the second set is 45. The mode for the first set is also 45. So let's do that. Now the mid-range, we add the highest and the lowest and then divide by 2. So that gives us what? 78. 62 plus 16 is 78. 78 divided by 2 is 39. So for the red set, we have 39. And I'm saving the mean for the end because that's the one that's most computationally challenging. 45 plus 33 is 78. 78 divided by 2 is also 39. Okay, so calculating the mean, the median, the mode, and the mid-range for all of these, or both of these sets, all of them, all 2 of them, you see that we get the same values for each, which might lead you to think that these companies are like exactly the same because all of the measures of center are the same. But we know that that's not the case. We know that company 1, the red one, is spread out over a much wider range than the company 2. Okay, so and if you think about it, our mean, I'm going to draw that in black on here. It's not part of the box plot, but we're going to plot it on here like this, is at 39. So which one has a higher standard deviation and which one would have a lower standard deviation? Well, standard deviation tells you how much the values differ from the mean or vary around the mean. And so clearly the red one varies much more around the mean because it's so spread out than the blue. Okay, and so company A would have a higher standard deviation than company B. So I'm going to say that. Company A, so standard deviation of A would be greater than the standard deviation of B. And I'm actually going to leave y'all to calculate that on your own because this is already getting a little bit long and this was just the preview. So I'm going to let you work on that on your own. If you have questions about calculating the standard deviation, again, we saw examples in 12.4 in the measures of dispersion. You can either make the chart or you can use that fun formula. But there are a bunch of examples like these. And so my suggestion is to go through them and practice. And if you have any questions, be sure to email me. All right, thank you, and make sure you watch the next video, which is actually diving in and looking at the normal curve.